My name's Stephen Kitt, and I work for Red Hat on OpenDaylight. I'm involved in ODL parent and OVSDB networks mostly. So as you've heard all day, I think, in a number of talks it's been mentioned that OpenDaylight isn't really something that you can use directly. It's more a toolkit that you can use to build applications on top of. And if you're trying to do that, it's nice to know how to build robust applications. So the first thing is, what do we mean by robust? Robustness in IT can refer to a whole bunch of different things. It could be resilience, high availability, clustering, and so on. And I'm going to be focusing on robustness being well-tested software. And we all do that, don't we? Develop well-tested software? Absolutely. And well-tested software is retested software. So you don't run your test just once. You run it several times, and that's why you employ lots of testers, don't you? No, you don't. You end up trying to make your applications automatically tested, because anything that can be done by machines instead of humans is probably better in the long run, at least in this space. And so automated tests, that's the definition. Tests carried out without human intervention. So you can run them, rerun them as many times as you want. They can be quick or they can take a long time. It doesn't really matter. All you get is a notification when something goes wrong, something changes, your test fails. And so that's when you need human intervention to actually go in and see what's happened. So what does that give us? Does writing more automated tests give us more robust applications? I'm not sure that follows directly. There's one thing that follows for sure, and that's that more automated tests gives you more time for more manual tests. Anytime you're not spending rerunning the same old tests that you know inside out, it's time that you can spend building up more complicated tests manually. And then, of course, more manual tests means more automated tests because you've got more scenarios that you can try to automate. And more automated tests means fewer regressions, because as you develop, change your applications, you've got all your automated tests running all the time, and they'll hopefully catch any change you make that's introducing breakage of one form or another. So now, in OpenDaylight, what kind of automated tests do we have? Well, we have three big types. Unit tests, integration tests, and what we call CSIT. So I'll go into the detail of all these. First off is unit tests. If you're familiar with development practices nowadays, you might have some idea of what these are. Often they're quoted as being small, defined as being small. I wouldn't say that's the most important part of it. From my point of view, the most important aspect of unit tests is that they test a single behavior. They might be quite big, but they test a single behavior, which means that if they fail, you know exactly what's gone wrong. They're close to the code, but they shouldn't be tied to the implementation. So that means that you're not actually you're not testing the code that's been written, you're testing the behavior of the system you're developing. So you're testing the behavior of the unit you're testing, hence the name unit test. And if you build good unit tests, there are a couple of nice side effects beyond just the non-regression aspect and the automated testing aspect of things. A unit test is in some ways an implementation of the specification. So you write your documentation that explains how you're supposed to use the code you're developing, and a unit test is going to be a sort of implementation of that that's different from the code implementation that provides the behavior. And another nice side benefit I find is that unit tests provide a first level of API smoke tests. And when you're developing an application, you're developing APIs, and ideally, your APIs are going to have users, so other developers using your code. It might be yourself now or a few months down the line. It might be other people. But if you write unit tests, these unit tests are going to be using your APIs, and that constitutes a first level of actual use. And you'll realize when you're writing your unit tests whether your API is easy to use or not. And if your unit tests are hard to write using your APIs, then there's a fair chance that real-world code that tries to use your APIs is going to be hard to write as well. So you might want to take another look at your APIs to improve the APIs and the unit tests and the code that other people write or that you write that uses these APIs. Unit tests and open, so this was all sort of fairly general around unit tests. What kind of unit tests do we have in OpenDaylight and what are they for? So unit tests in OpenDaylight, they are each project's responsibility. It's not up to, there's not sort of somebody in the Linux Foundation or in OpenDaylight as a large project chaperoning all of this stuff. Each project has its own unit tests, and it's up to each project what kind of unit tests they want, how much effort they put into them, and so on. There's a fair number of unit tests. When I was putting these slides together, I ran a quick grep through all the code in OpenDaylight. So this is in the development branch. Then we have around 30,000 unit tests, which is a decent number, perhaps not enough. You can always have more tests. And they're not all high-quality tests either. But it's still, it's a good, it's nice to know there's that safety net at least already. Unit tests in OpenDaylight are all run for every single commit. So every time a developer writes some code and pushes it to the development infrastructure, all the unit tests in the project that's concerned are run against this new code. And in theory, code can only be merged if all the unit tests pass. There is one caveat to this, which is that it's only the affected project's tests that are run. So when you make a change, for instance, to Yang tools, you might not be familiar with the OpenDaylight projects, well, the way it's split up. But if you make a change to one of the projects, then it might break some unit tests in some other project, and you won't realize that straight away. That happens every once in a while, but it's quite hard to. It would be quite hard to change because running all the unit tests in OpenDaylight takes around a day. So if we had to wait one day for every single patch, it would take it would slow down development quite a lot. We keep histories of all these tests being run, and so you can have a look at. You can see how well-behaved the code is with respect to its unit tests as time goes on, and also how long all the unit tests take to run, and various other statistics. And as I said before, they are required to pass before merged in theory. So in practice, you can always force a commit to be merged if you really want to, because sometimes there are infrastructure issues which make all the unit tests fail for reasons which have nothing to do with the code being changed. And we need the patch to get in, so we force it, but that's not the standard practice. And you can see here, this is a screenshot of Gerrit, our code repository management and workflow system. And at the very top on the right-hand side there, there's code review +2 and verified +1. Verified +1, that's the Jenkins test bot that said all the unit tests have passed. And normally you need both of these to be approved before a patch can go in. Yeah, so you can see here verified +1 and the detail down there with the link to the build. All this is also tracked in Sonar, which is our code quality measurement, well, the code quality measurement tool that we use in OpenDaylight. Oops, sorry. And there are nice graphs that go with it. And so this is a screenshot from OVSDB, and you can see here the coverage in unit tests, 38.4%, and details of the coverage on the right-hand side. I'm not going to go into that too much, but you can take a look if you're interested. So the next type of tests, automated tests we have in OpenDaylight are integration tests. Now these, generally speaking, well, they're known as integration tests because they integrate multiple behaviors. Where unit tests verify a single behavior, integration tests bring together multiple systems and verify more complex behavior. That also means that they tend to be closer to end users' expectations and actual use cases. They don't have to be, but this is where you can start actually taking your end user requirements into account and building scenarios that mean something for your end users. And so integration tests, they have other side benefits like unit tests. They're the first level of implementation of actual use cases, like I just said. And so this gives you a more comprehensive look at how your system supports end user behavior and how easy it is for other users and developers to use all the systems you're developing to actually do something useful. And again, same as for unit tests, if it's hard to write integration tests, it's probably hard to write useful applications with your APIs. And again, more API smoke tests. Integration tests in OpenDaylight. So same as for unit tests, these are the responsibility of each individual project. And so some projects have got lots of integration tests, others have none at all. There's no big cop that tells them they're doing things wrong. But we still have around 300 integration tests. So that's 100 times fewer than the unit tests, but it's still quite a large number because integration tests take a long time to write, and they tend to take a fair amount of work to maintain as well. And these integration tests, they include a number that are fully automated, but some that also require non-automated setup, and so these aren't run automatically. And so this sort of tends to cover tests that require an open vSwitch, for instance, to be brought up. And so the plain integration test infrastructure we have can't handle that. There's other stuff that does. But.
Can I just ask a question?
Yeah.
Is there a general philosophy in OpenDaylight around creating test cases?
No. I'd like us to develop one, but there isn't one currently. Yeah, which is why I mentioned that it's up to each project for unit tests and integration tests at least. Yeah. So integration tests, like unit tests, yeah?
Maybe get a little bit into mature integration.
Right, but aren't they defined more in terms of system tests, CSIT? I'll come to that in a little while. So same as in unit tests, integration tests, most of them, so all the fully automated ones are run for every single commit, which means that you can't really have complex integration tests at this level that take a long time to run. Most of them are required to pass before merge, and they're not distinguished from unit tests in Gerrit. So they contribute to the verified +1 thing I showed you earlier, and there's no distinction. If a unit test fails or if an integration test fails, it counts the same.
Maybe explain the difference between commit and merge.
Right, so a commit is one set of code. So yeah, Phil's comment was maybe explain the difference between commit and merge. So when you write a set of code changes, that's a commit. And when it's actually approved and integrated into the code base, that's when it's merged. And we'll talk about merging it. So coming back to integration tests, so they're not distinguished from unit tests in Gerrit, but they are tracked separately in Sonar. So this was, if you remember the screenshot I had just a few slides ago, when you scroll down on that page, you get a separate table with IT coverage, and this is integration test coverage. And you can see here, this is the same project that had somewhere under 40% coverage globally. It's actually got 59% coverage of integration tests, which is nice. And finally, the last type of automated tests we have in OpenDaylight, and the most interesting ones in terms of project lifecycle and workflow is what we call CSIT, Continuous System Integration Tests. So these are another type of integration tests, but they have external requirements. So this is where really you should put the integration tests that I mentioned earlier require Open vSwitch or Mininet or separate VMs to run a controller or some special workload. And they allow us to cover full-blown system tests with tests such as clustering, scalability, how your workload handles, if it stays alive for a long time. So this is much more than just testing a single behavior or a sort of end-user use case. It allows you to cover, well, anything really that you can automate can be a CSIT. And so in OpenDaylight, CSIT is different from the unit tests and integration tests because they are a release commitment. Every single project in OpenDaylight that participates in a release is supposed to commit to having at least one system test for each OSGI feature. So that's one way of packaging functionality. The details don't really matter all that much, but anything that's exposed to the end user is supposed to have a system test, and projects are also supposed to provide large-scale system tests for all the functionality they provide, their clustering capabilities, if they advertise clustering capabilities, scalability, performance, and longevity and stability. So that allows us to ensure that release after release, we maintain the same level of quality or improve it, well, in theory at least. So these system tests, they're managed by each project and the integration test project. So this is, again, different from the unit tests and integration tests. There's a collaboration and some measure of external auditing of system test relevance and quality levels, and also some amount of external help. If a project goes to the integration test team and tells them, we're struggling a bit with setting up this kind of test, can you give us a hand? They'll probably pitch in quite willingly, as Phil was saying earlier, and Neela as well. If you ask for help in the OpenDaylight community, you tend to get it. And so with all these requirements in OpenDaylight, we have quite a few system tests, around 4,000. But the integration test team would tell you that that's not enough. Yep. The tests are run daily, not for every commit. And so that means that there's no gating associated. So you can fail your system tests and still merge code into the development branch. You won't run into trouble for it now, but you'll run into trouble for your broken system tests as you get closer to the release. And you'll get the integration and test team and Phil and others on your case. Same as everything else, all this is tracked. So this is our Jenkins tool that's used for running all the test jobs. And you can see here, these are all the OVSDB CSIT tests with various types, 1-node, 3-node clustering, etc. And they all have a number of passed and failed tests on the right-hand side there. And the little robot logo, that's because most of these tests use the robot framework, which is a quite nice framework for writing nearly human-readable tests. At least more readable than when you're writing pure Java code. So you can see here, well, maybe not all that well, but the tests have human-readable names like create original cluster list, check shard status before fail, start OVS multiple connections, and so on. And so all these tests, they also contribute to the life cycle of the project within OpenDaylight community. That's what Phil was asking me about earlier. When a project starts out in OpenDaylight, it's an incubation, which means basically OpenDaylight provides, hosts a project, and so you get access to the infrastructure and so on. But there aren't all that many requirements on the project itself. It's more a sort of sandbox that you can try and develop your idea in without spending an awful lot of time and money setting up all the infrastructure. But if you want to move on to other sort of project statuses like mature, then you need to set up system tests and have them passing, or have them be meaningful and have them pass all the time, or a fair amount of the time. And a feature, so projects globally can become mature, and we also track independently of that features that are available to end users that can become stable, and that's also tracked with system tests. And there's a set of rules where you're only, if you have a stable feature, you're only supposed to use other stable features and so on and so forth. And the idea is to progressively build a stable, safe subset of OpenDaylight that you know is well tested, regression tested, and so on, and that you can use as a solid foundation for your applications while still allowing for other stuff to be developed on the side. Now, where all this becomes really interesting for people who are developing applications on top of OpenDaylight is that you can apply all this stuff to the code that you're writing, whether you're writing it within OpenDaylight or as an external project, in your company. You can write unit tests and integration tests and so on, and use all the frameworks that we have. I'll go into that in a little while. And you can also connect your own build systems to OpenDaylight's build systems. And so nobody has actually done this yet. A few people have talked about it, and I'm talking about it because I know that the foundation's open to it. And the idea is that you could have your own CI, your own continuous integration systems running in-house, pulling code from the OpenDaylight repositories, so you get notifications from OpenDaylight when code becomes available for testing. You run your own tests in your in-house integration system, and you can vote back on Gerrit. You know the verified +1 thing? You can do that from your own tests, running on your own systems. Perhaps they can run tests against your own hardware that you keep in-house, that OpenDaylight doesn't have. And you're still allowed to vote on patches going into OpenDaylight, which I think is very cool. So how do you do this? How do you use all this to build robust applications? Well, as far as possible, I'd encourage you to test upstream. So if you have already built test scenarios that use the parts of OpenDaylight that are relevant for you, but nothing else, or that you can reduce so that they use parts of OpenDaylight and none of your systems, then please consider contributing them upstream, because that'll mean then that your use cases are regression tested against all the development in OpenDaylight will be regression tested against your use cases without your involvement. This is one of the nice leverage effects that you get with open source development. So contribute your use cases. Also write good tests if you want to build robust applications. So this is just general testing practice, test for behavior, not implementation. So I've got a couple of examples here where we have a bad unit test that runs some test and then verifies that specific methods have been called. That doesn't work because as soon as you start changing the way the function is implemented, your test is going to break. Likewise, test your code, and not the infrastructure. There's no point in you writing unit tests for stuff that's provided by OpenDaylight infrastructure that you rely on. Well, there is a point to doing that, but write your tests in the upstream infrastructure. And in your tests, use the infrastructure. I see an awful lot of tests that go out of their way to avoid relying on infrastructure because for some reason they don't trust the infrastructure. But there's an awful lot of interesting stuff that you can use to make more relevant tests. Like for instance, we have a stub MD-SAL implementation that can be used in tests. And so this is an example of a test that tries to do operations against the MD-SAL, so the data store in OpenDaylight, and it fakes stuff. So the test doesn't actually mean anything. And if you rewrite it using the actual test MD-SAL, it's much better, much more, well, easier to write for a start and more meaningful. So I won't go into too much detail because it's quite complex. Well, quite. But if you're interested in that, come and talk to me. So this is still the same thing. And then we also have some other nice features like project templates. This one's called Features Parent. And if you use that for your features, then you automatically get a certain number of tests that are applied on your system. A general pattern that I find very useful, but it turns out isn't all that known, is to write your tests following a given, when, then pattern. So I'll go over this very quickly. The idea is that you start off setting up a certain state. Then when something happens, this is the behavior you want to test, then you verify the effect. And the important part is to keep that order and keep those three things separate because it makes your tests much easier to maintain and much easier to read. So here's an example, but you can't read it very well. What this brings you, the benefits this brings you is that when you write tests this way, if your API doesn't change, your tests shouldn't change. And that means that you can rewrite your implementation. If your API doesn't change, your tests don't change, and that gives you a very, very useful safety net. If your API changes, but the functionality itself doesn't change, so you're just changing parameters or something like that, then the when part of your test changes, but not the then part. And that's useful verification again. And then finally, if the functionality itself changes, then the then part of your test changes. So a couple more remarks. Complex code is worth making testable, and that might mean changing the code. You need to maintain your code as you maintain your code, but you also need to maintain your tests as you maintain your documentation, because your tests are related to your APIs and to your documentation, not so much to the code itself. So in summary, build tests, automate them, push them upstream, know what you're testing, use the infrastructure that we provide, ask us about it. It's not all that well documented. We need to document it more. Tell us what you need, and we'll try to give it to you. Ensure your tests are maintained, and we're pretty much out of time. But thank you for listening. So what does that give us? Does writing more automated tests give us more robust applications? I'm not sure that follows directly. There's one thing that follows for sure, and that's that more automated tests gives you more time for more manual tests. Anytime you're not spending rerunning the same old tests that you know inside out, it's time that you can spend building up more complicated tests manually. And then, of course, more manual tests means more automated tests because you've got more scenarios that you can try to automate. My name's Stephen Kitt, and I work for Red Hat on OpenDaylight. I'm involved in ODL parent and OVSDB networks mostly. So as you've heard all day, I think, in a number of talks it's been mentioned that OpenDaylight isn't really something that you can use directly. It's more a toolkit that you can use to build applications on top of. And if you're trying to do that, it's nice to know how to build robust applications. So the first thing is, what do we mean by robust? Robustness is in IT can refer to a whole, make your applications automatically tested, because anything that can be done by machines instead of humans is probably better in the long run, at least in this space. And so automated tests, that's the definition. Tests carried out without human intervention. So you can run them, rerun them as many times as you want. They can be quick or they can take a long time. It doesn't really matter. All you get is a notification when something goes wrong, something changes, your test fails. And so that's when you need human intervention to actually go in and see what's happened. A bunch of different things. It could be resilience, high availability, clustering, and so on. And I'm going to be focusing on robustness being well-tested software. And we all do that, don't we? Develop well-tested software? Absolutely. And well-tested software is retested software. So you don't run your test just once. You run it several times, and that's why you employ lots of testers, don't you? No, you don't. You end up trying to... And more automated tests means fewer regressions, because as you develop, change your applications, you've got all your automated tests running all the time, and they'll hopefully catch any change you make that's introducing breakage of one form or another. So now, in OpenDaylight, what kind of automated tests do we have? Well, we have three big types. Unit tests, integration tests, and what we call CSIT. So I'll go into the detail of all these